Hey everybody, this video is going to be talking specifically about one sort. We talked about sorting already, I kind of introduced you into the topic. Today is going to be a discussion of specifically BubbleSort. So I'm going to have some code, we're going to go through how it basically works. There we go. Alright, so this is of course BubbleSort in Python. Now I've already sorted some things here. And I did this kind of ahead of time, so we can kind of see this, because this particular sort's going to take a little while. So first I want to point out this. I did BubbleSort on about 100,000 numbers. And it took this computer 616 seconds to sort everything. This is my laptop at work. Just to give you an example, if I were sorting 10,000 numbers, which we'll see here shortly, it takes about 6 seconds. So it's 10 times more every time I kind of go up a zero, I guess you can say. My home computer will do the 10,000 in about 2 seconds. So, but it is vastly more spec'd out than anything here. The lab computer I worked on earlier took about 10 seconds to do 10,000 numbers. And I think a grand total of 18 minutes to do the 100,000. This took 10. So you can kind of see, it does matter what kind of system you have when you're doing this. But let's get into the actual coding of everything. So first off, I want to point out big O notation. Now I had to study this when I took data structures back in the day. And I'm not going to have you do math problems on this like I had to do. Just know like which of these is faster and slower. That's really all I'm requiring. So as far as big O notation, as you see here, 1 means basically you do it and it's done instantly. O of 1. O log n's a little bit more than that, as you can see right here. And O in, you see the little line goes from here to here. That means the more you have, of course, the longer it takes, but it's still incredibly fast. Now, most sorting algorithms that we use are generally going to be, or at least let's just say most of the good sorting algorithms we use, the merge sorts, the quick sorts and stuff like that, would be in log n. So you see the curve kind of goes up. This is like, the more items you have, this is how quickly the time goes up. Now, this is where we get into some of these other sorts here. N squared, 2 to the n, and then n factorial. Now, of course, this would be basically, if I have 1, it takes X amount of time. If I have 2, it's that much more. 3, it would be, it would take way more as I go up. It just gets worse and worse and worse with every one little thing I add. Now, we're going to be looking at our first sort, and it is going to be called BubbleSort. Now, BubbleSort, I'll just go to BubbleSort here. I like this site here because it has a nice little visualization of what this thing does. BubbleSort is n squared, essentially, because of it. Well, it depends. If it's already kind of nearly sorted, it's actually n. But if everything's really randomized, it's n squared. So it depends. If stuff is most nearly sorted, it actually finishes fast. So if I run this, you'll notice the nearly sorted finishes almost immediately. Everything else, however, is going to take some time. There you go. Now, if you notice what it's doing here, and I'll restart it so you can see this, just watching it tends to give you a good idea of how this sort works. There we go. So it finds the smallest number, or rather the first item here. It'll go through my entire array or list, find the smallest number, and then it will start swapping it up until it gets to the top. Now, the reason this is one of the slower algorithms is simply because, well, it does an insane number of swaps to get it up. If you see right here, it's going to take that. If this thing was completely reversed, that's the worst case right here. It literally has to move every little item up, up, up through every single one of those. Notice it's swapping constantly all the way up. Then it goes a little faster as we go down because there's less places for it to swap up to get to where it needs to go. So this is one of those things that ramp up as we go through it. Of course, again, reverse is kind of the worst case there because you will have to make the maximum number of swaps. So BubbleSort's very simple and easy. Here's kind of the algorithm for it. You'll see you just have 2 for loops, and then we have a little if statement, compare, and we have a swap, and we have a couple of little bits of code here, to make sure we swap things. And that's it. It's really just like several lines of code to do this. Now, some of the more advanced algorithms take like several more times this amount of code. So you might ask yourself, well, why would you do BubbleSort at all? Well, most people wouldn't. You would use a built-in sort that's built into most languages, which is usually like a quick sort type of sort or something like that. They're usually just built in. Whenever you go array.sort or something like that in Java, for example, it uses kind of a hybrid quick sort, if I remember correctly. I think Python's kind of similar. They're built-in sorting mechanisms that you can use. Of course, if we want to know how these different algorithms work and how they function and know why they are efficient and why they're not, it's better to put them together. I mean, we can always use built-in stuff, and you should when you're like creating a program yourself. But the point of this class is to learn how they work so you can explain it and know why they work. Sometimes the built-in thing just isn't going to work for what you need to do. Sometimes you might have to build something from scratch. Maybe you have to modify it to work with something else. So in that case, what we got to do is understand the basis for why these things do what they do, why they suck as much as they do, or do well, depending. It could be the difference between like playing a game and suddenly it stutters and drops to like 20 frames per second, and then it shoots back up to 60 or 100 and something. Because somebody coded an algorithm badly, and it keeps getting hung up when it has to process it. So, let's take a look. If I were to run this entire thing, you'll see these are all the different sorts we're going to kind of cover in class. Maybe not heap sort, but the quick sort, merge sort, and all these others. And if I run them, they'll all kind of go at different speeds. And as you'll see, these over here are done. Shell sort is kind of an abnormal sort. I kind of separate them between loop sorts and then your recursive sorts over here, which get finished using recursion, whereas these use loops. And for whatever reason, shell sort is an incredibly efficient loop sort, probably the best out of all of these. It can actually almost keep up with some of these others, but it's also vastly more complicated. If we just take a quick look at the algorithms for this, well, the algorithm may not look as complex, but you see there's some division by 3. There's a couple of other things in here. We'll see the code later, but it is a little bit more complicated than just your simple bubble sort. We'll see selection and insertion sort later as well, but they're not so different from bubble sort. They just deal with things a little differently. Bubble sort will find the smallest number and bubble it up to the top, and then the next smallest number and bubble it up to the top. That's effectively what it's going to do for the whole thing, and it's going to swap every time it moves it up, which means if we put a little print statement there or a counter, you would find that even for let's say a 10,000 array, if it was backwards, it would make literally 10,000 swaps to make it up to the top. Each of those swaps are milliseconds, like hundredth of a millisecond or whatever. But when you're doing tens of thousands of them, then that adds up. Then the next one will be 9,999, 9,998 swaps. You kind of see how that goes. There are better ways to do this, but this is the easiest one to code and see how that works. So let's see the code for this. I did 100,000 on this computer here, and it's 616 seconds to sort. We'll start with a small number here once we go through the code, and then we'll just keep this 616 in mind here. Oh, this was 10,000, by the way. Anything less than that, it's less than a second. But if I were to try to a million, it would take an hour or something. It would be ridiculous. More than that, actually. So let's take a look at the code. Now, I've got a couple of little bits of code here that are outside of my BubbleSort algorithm. This is my BubbleSort algorithm here. But I've got some other parts in here to kind of help illustrate a few things here. This is the actual algorithm for BubbleSort, just so you can see it. Now, I've included a timer in my code and a random fill so I can randomly fill my array each time I do this. This first bit of code here, and feel free to pause when you're ready, is basically going to be used before we run our sort. This gets basically a timestamp of that particular time. The function BubbleSort runs, and then we do the end timer here, which will tell us how much time has elapsed. The thing that I'm passing here is just the name of the sort, and in this case the start time as well. So this is going to return the start time. I'm going to save it, and then I'll pop it back in here so I can do the math and figure out how much time has elapsed. And then it'll say, you know, BubbleSort 10,000, timer ends, and this is how much time it took. So all this is just to figure out the time. Time.time gets us, if it's just like Java's time.millis, it would get us how many milliseconds have passed between now and January 1st, 1970, which is a lot of milliseconds, in, you know, huge number. But if we timestamp it, and then timestamp it again after this finishes, we just subtract, and then we know how many milliseconds have occurred between those two operations. This is also used in animation and that sort of thing, when you want to know when the next frame of an image has to be displayed to make it look like it's animated, to make it smooth. You'd usually have some sort of timer or something, or sleep it for a certain amount of time, or something there to keep track of that time. Now I've got a fill here that will fill my array or list. Now I thought about maybe adding like not the size, but the number range as a variable up here, and you could. I decided just to leave it at 0 to 10,000. That should be more than enough for what we're doing. You could even make the range even bigger if you wanted to. But this right here is the range. So what I'm doing is, I've made an empty array later down in the main area, and I'm going to pass it up here with a number. And that number is the size I want this thing to be. So it will go for, like if I say 1,000, it'll go for 1,000 turns and just add 1,000 numbers to that empty array. 0 to 10,000 randomly. That's what this line does. If I want it to be bigger, well, then I just add some more numbers and it's bigger. Pretty simple, pretty straightforward. If I want that to be a variable, well, then I could just pass, you know, rand here, then type rand there, and, you know, I could tell it the specifics of the randomness it needs to be. Min rand, max rand, if I want to like be more specific. But 0 to 10,000 is fine for me. Now, this is the actual sort code here. So these are all the extras. BubbleSort, if we take a quick gander here, this is the algorithm, and this is the code we've got written. So let's take a look. We have a loop that goes through the entirety of the array. Well, look at that. And I have a function here. I pass the array in. There's my loop that goes the entirety of the array. We have our swapped variable right there. We have another loop. Now this is going to be the thing that, this loop right here controls the swaps as I go up. And once I get to my location, it'll be where it's supposed to be. And then this one will move us down one more slot, and then we'll use this to go down and find the smallest number and swap it up. So we have our if compare. Now we have our swap. There's our swap. And then we have our, we set our swap to be true. Oh no, my thing went away. Let's bring it back. There it is. And if we didn't swap, then we break out. So you see the code is pretty much exactly the same. There are some minor differences between some of these pluses and minuses, but that varies depending on the program, depending on how you set it up. We'll double check and make sure these things are sorting like we're supposed to. But that's BubbleSort. So far we've got timer begin, timer end. We got our fill to fill with random numbers. Then we got the actual BubbleSort code. I have my main down here. And if you note, I put these little comments at the end of that just because I find it helps keep me a little better organized. This is supposed to be the beginning and the end. Most other languages outside of Python have some sort of brace or ending, and I usually put comments after those because I find it makes it so I don't break my program as much. It makes it easier to spot errors. So I do it here too. That way I'd be consistent if I went to another language. And again, I think it just feels more organized. All right, so I'm gonna make this small, let's say 100, and I'm gonna have my print statements here. There we go. So I'm gonna print the unsorted array, we'll see it. There's an empty array, there's my fill that fills it. I'm gonna print it so we can see that all the numbers are in wonky order. We'll start the timer on BubbleSort, let's just say like 100. I will BubbleSort it, and then I'll end the timer after it's sorted. And then we'll print, and if the sort worked, all of them should be in numerical order. So let's take a look. I'll run it, and this is with 100 items. And you see it's pretty much instant. In fact, it was so quick it couldn't even really get, it would be less than like 1,000th of a millisecond, of a second, essentially. So it took no time at all. We've got 9,000s and 6,000s and 7 and 8. If we look down here, it does indeed look like it's sorted. So we know it's sorted. It just did 100 numbers. We can run this a couple of times just to make sure if we want, but it works. So I'm going to turn that off because that's going to be really tedious going forward here. So especially when we get to some bigger numbers. Let's make it 1,000. And I'll run it. That took, oh look, we have some time, 0.04 seconds. So if I make it 10,000 and run it, and this should be around 6 seconds, I think, 5, 6 seconds, there we go. And I am not going to do 100,000 simply because, so it was 10,000, right? We'll run it one more time, see if I get a slight variation in the speed. Again, this is my work computer, so this takes about 2 seconds or less on my home computer, so you can tell the difference in specs. But this up here is what I did earlier for the 10,000. This is the 100,000. So you can see it took 616 seconds. So we're not going to sit here for 10 minutes and let that sort. But this should hopefully illustrate that curve I was showing you with the big O. You know, the more you add up, the just more exponential it takes, more exponential the time is it takes to finish. So with fairly small lists, you know, a BubbleSort's quick, it works. It's not super efficient or anything, but it doesn't use a lot of resources per se. I mean, on a small array, it doesn't really matter. You won't even notice it. It doesn't start getting noticeable until our array starts getting bigger and bigger and bigger. Still, it's better to use, you know, something that is built in because it's tested. You know, it's not going to break. You know, it's going to work. But this hopefully gets you the idea of how this works. That way, when we go forward, you know, you'll be able to compare this to those other arrays, or not arrays, but sorting algorithms that we look at. And that's why I have the timers. So as we go through this, each one of these will set timers up and we'll kind of compare and contrast. We'll see visually how they sort, and then we'll check the time on how they sort. We kind of want to do those on the same machines That way, you know, if I did this on like one of these on my computer here and one of those at my computer at home, I'd get some really wonky results because there's just such a great difference in specs. So you kind of want to do like all the sorting on one, that way you can kind of compare and contrast. But that is kind of the quick breakdown of BubbleSort, along with a couple of little extra functions there to kind of make it a little easier to see. If you have any questions or concerns or comments, then just let me know.